Today, we're going to prove that if you have two sequences of real numbers and a and b are real numbers, if the limit of an is a and the limit of the bn's is the real number b, then the limit of the sum is a plus b. And like always, we do proofs like this using the definitions. It's all done by definition. So the first thing we're going to do is write down the definition of the first piece they gave us, the proof. They told us that the limit as n goes to infinity of a sub n equals a. Well, this means, now we know this limit exists and it equals a. We're given that. This means that given epsilon greater than 0, it does exist in n1 such that whenever the subscripts, little n's, are bigger than n1, we always have that a sub n minus a is less than epsilon. That is, the a-n's and the a's, the difference gets smaller and smaller. The a-n's approach capital A if n is bigger than a1. Okay, now we'll do the same thing for the b sub n functions. The limit as n goes to infinity of bn, well, that equals b. This is given, and b is a real number. It's the same as given epsilon greater than 0, it does exist in n2 such that whenever little n's are sufficiently large, we have that the difference between the bn's and the b's are small. Now notice that little n just has to be bigger than n sub 1. If little n is bigger than n1 plus a million, this would also be true. So I can get away with choose n to be the maximum between these two. That is, it's the larger one. Then we can say the following. Now, whenever the little n's are bigger than capital N, we have the following. We have that 1, a sub n's minus a are small. Let's say epsilon over 2. I'm anticipating the over 2, so when I add, I'll just get epsilon. Epsilon over 2 plus epsilon over 2 is epsilon. And the bn's minus b is also less than epsilon over 2. So I'm only talking right now about when n is bigger than capital N. So this statement is true, and it can be written like this. A sub n is less than a minus epsilon over 2, and a plus epsilon over 2. And this statement can be written as b minus epsilon over 2 is less than b sub n, which is less than this. Okay? That's just rewriting these two statements in a different way. All of those two statements are true, well then when I add them, a plus b minus epsilon is less than an plus bn is less than a plus b minus epsilon. That should be true. Taking away a plus b from both sides, I get negative epsilon is less than an plus bn minus a plus b, which is less than, it should be plus epsilon, less than epsilon. But if this is between negative epsilon and epsilon, that means that the absolute value of this must be less than epsilon. But again, every statement that I just wrote is when n is bigger than capital N. So, given any epsilon greater than 0, there exists an n such that whenever n is bigger than n, we have this statement. We have the absolute value of an plus bn minus capital A plus b is less than epsilon. But that's the same as the definition of a limit. That's the limit as n goes to infinity of this a sub n plus b sub n equaling that a plus b. Theorem has been proved, all by definition. And knowing that I wanted to end up with epsilon, so I let the individual pieces be less than epsilon over 2, so then when I add them, everything works out nicely. See you in the next video. Watch and learn.